Hey, welcome back to Red Blue Labs. I've got a good video for you today. It's about Wireshark, as you can see in the title. I've been requested by a few viewers that they would like more information on a particular part of the Wireshark process. Specifically, they'd like to know more about what do I do when I first get a wire capture, and I've been told that there's something potentially malicious on it, or I need to find a weird piece of traffic on it. What do I do? What are some of the steps? And so what I've done here is I've collected some of the questions that people have given me, and I'm going to be making this video. There's a wide variety of videos from people that are just learning about Wireshark. Some folks that have been teaching and networking for a few years have said, hey, I would love it if some new students would just like have a nice good push and have some of this information regarding Wireshark. So this video is broken up into parts. In a bit here, I'm going to show you sort of like the objectives that I'm going to be covering. But it should be a good time. I'm going to show you some things that I've learned, and all the things that I've done that are in this video are things that I've gleaned from reading, and also gleaned and learned from experience. And so I will reference things that are specifically, maybe I've named it myself, or this is something that is unique to me, but I'm going to demonstrate my process when I'm given a capture for the very first time. Alright, let's get right to it. Alright, here we are, we have the outline for the video, and I'm going to quickly go over these outlines, and this is essentially what I want to accomplish in this video. And if you want, you can, if there's something specifically on this outline that you want to jump to, then by all means skip ahead in the video and go on to those parts. So we're going to talk about who is this video for. That's what I'm going to do right away. Why Wireshark? I'm going to show you some examples of preparing Wireshark to help you visualize some of the traffic that's happening in your network, changing some of the features in Wireshark to make things a little bit easier. We're going to look at my initial interactions, which would be right over here. What do I do first when I look at something, capture, and I think, okay, what do we get here? What are we doing here? And I'm going to show you some key areas inside of Wireshark that I usually land on first. Okay, and if you do that process as well, it'll probably make your life a little bit easier. What does malicious mean? And that's a really good question, and this could mean different things to other people, but I'm going to tell you what I think it means, and I'm going to do a little bit of a lecturing, I guess, on the topic of what does malicious mean. And then I'm going to wrap up the video with identifying a scan and identifying floods on a network. Okay, so who is this video for? So you may have heard of Wireshark. You may have opened it once or twice, and you've got a little bit of experience with it. This video would be more for you. So if you've got like a lot of industry experience with Wireshark, there might be pieces inside this video you might find informative and might learn something from. Maybe when we get to my initial interactions, maybe there's a way that you could modify your process a little bit. What does malicious mean? You know, I think it's helpful to hear other security people talk about what did they think malicious means. And then you've probably, if you've got a lot of experience, you've probably seen scans and you've seen floods, and so this might be redundant for you. But this in general, this whole video would be very useful for folks that have limited experience to Wireshark, or are just getting started and are wanting to learn more about how to identify things that are abnormalities on the network. Okay, so that's who this video would be more for. And I'll jump to the second outline. Why Wireshark? Well, and we've got a lot of other tools that we can use in the command line, which we should be practiced in using. TCP dump would be a very good example, where we can watch for traffic, and we can filter with it, and it can pump out on the terminal and give us what we need. But Wireshark is a very, very useful because it's got a lot of features. It's got a lot of ways to manipulate the GUI. We can filter very quickly on various things that we're seeing inside the capture, and it's very verbose, and it can seem very daunting at first. And I hope that this video can sort of alleviate some of that stress that people feel when they first open up Wireshark. But Wireshark is widely used in the security world, and of my top tools that are my top favorite tools, Wireshark's right up there. So I've got my top 3: Nmap, Wireshark, HPing3 are like my top 3 favorite tools that I like to use, and I use Wireshark a ton. And so getting practice with Wireshark is a really good thing to put on your resume, saying I'm skilled at using Wireshark. You can have a blog or a website and say, hey, these are my I can demonstrate some of my things that I've learned using Wireshark. Okay, so highly recommend playing around with Wireshark, gaining exposure to it, learning about it, doing scans and floods on your own private network. Okay, and seeing what does it look like, and then trying to observe what is different between what I'm doing and what I'm seeing in a normal environment. It's super important. I love Wireshark so much. Okay, we're going to jump over to preparing your environment. So I'm going to demonstrate some ways that we can manipulate Wireshark to make our GUI a little bit more friendly, make it a little bit easier to view key things. And these would be things that I would like to see first. So, for example, like destination port and source port. Those are really useful things, especially when we're looking at scans and floods, and just in general, like where is this traffic coming from, and where's it going to, and where in that TCP communication are things happening. Okay, let's jump on over to preparing our environment. All right, so here we are. I've got Wireshark open. And what we're going to do here is that we're going to tweak Wireshark just a little bit to make our life a whole lot easier. Because when I'm analyzing packets, there's key things that I like to look for in every packet, and so I like to have it visible right away. Okay, so what we're going to do is we're going to go and modify, or let's create actually a whole new profile. So let's jump over, and we're going to look at the bottom right hand of Wireshark. And as you can see right here, I've got my profile here, but we can choose a variety of profiles. So I've got a default Bluetooth Classic. I've got the one that I made, and then I got a Group A. But we can do other things. So let's go and take a look at what default looks like. So there's my default one. Let's go and jump back over to the Wireshark, and we're going to grab some packets very quickly on a interface that is connected. So I'm going to choose Ethernet here, and we're going to grab some quick packets. So that's it. I'm happy with that. And what I want to look at most is what does the GUI look like with the default setting. Okay, so let's take a look at that. Okay, so this is the default settings that you get when you open up Wireshark. You have columns in our display here, and we've got a number, which we can see is sequential counting up. We have time, so that's when the packet occurred. Source, that would be who on this network did this packet come from. Destination, who is that packet going to? And then we can see that there are protocols occurring. Okay, and then as we know, protocols is the way that machines are able to communicate with one another. We've got TCP, we have ARP, we've got TLS occurring, and in this very short capture, that's all that we've got. The length of that packet, and then some information about that. Okay, and so that's what we have as default, but there's a lot more that we can have visually in this. So what I'm going to do is I'm going to show you how to make a profile, and then we're gonna modify that profile to give us the information that we want to see right away. So there are a couple places that we can make new profiles. The first way that I'm going to show you is actually if we go down to the bottom right hand side of the screen and we look over at where we've got profile here, and I give it a right click, and over here it brings up a pop-up menu and I can select new. Over here I can also import a profile that's been created by myself or by somebody else. I can export a profile with all of the particular settings that I've made and then give it to colleagues. This would be an efficient way to share profiles. But if you want to make a new one, you can do it there. Another way to do that is if we were to jump over to our main window here, and let's take a look at the edit. And so when I go on edit and I move on down to configuration profiles, I'll be presented with a window excuse me, and we'll see that I've got all of my profiles available here. So I can add profiles, I can remove profiles. So I'm gonna actually remove this one and give it, select that, and now it's gone. Let's make a new profile, demo profile, and hit OK. Now let's go take a look at the bottom right hand corner, and it's going to show us the profile that's currently being used. And then as you just saw, it's the demo profile. All right, let's go and make some tweaks on this profile. Let's go ahead and add a few columns. Now there's two columns that I always add when I create a new profile. Every single time I will add these two columns because it's extremely useful seeing particular ports right away. Because when we look at a packet, we can go down and we can dive down into the packet and see what was the source port and the destination port. We can do that, but I like to be able to see it like right away, because when I see it in this pane here, we can see very quickly visually some trends that are happening. Especially when we do some display filters modifications up here, we can see that maybe those ports are rising sequentially. Why is it doing that? Maybe there's a ton of packets flying at this one particular port. Why is that happening? So changing the visual layout of this is a huge help. Let's go into this profile. We're currently in demo profile, and we're going to modify some of our columns. So we go over here, right click, and we go to column preferences. And right away we can see we've got some things to select from, and I'm not going to go into all of these things. These are definitely some things that if you're wanting to dig into Wireshark, you should go in here and make some modifications. We can change our capture, expert, filter buttons, name resolution. You can filter on variety of protocols. This would be very useful for if you're going to be doing some IoT analysis. That'd be useful. RSA, statistics, stats tree, But what we're going to do is we're actually going to the columns, and I'm going to add a column. So now it's pretty easy. We've got a plus sign here. Let's go and click on that, and right away we've got our new column that we're going to have. I'm going to double click on this, and it defaults to number, but let's go and dive on down to the one that I specifically want. So I'm looking for source port. So let's go down, and we've got source port right away. And we're going to change its name, source port. I'm also going to add another column. These are the two columns that I add. Let's do that one. I like to see destination port. Okay, and we're going to hit OK. And they are all the way over here. So let's drag this next to source, and we're going to go to the destination port. We're going to drag that all the way over just after the destination. So we can see visually that we're dealing with the source IP, the source port, the destination IP, and the destination port. And right away you can see that visually you can see that this machine here, 1.70, was connecting to this IP. The source in this case doesn't really matter because it's It's just picking a random source port. But the destination matters because it's 443. We can tell that we're probably beginning the relationship of an HTTPS, or we're getting ready for a TLS, which is what we can see right here. So this is extremely helpful. So those are the two columns that I add right away. Now there are a lot of ways to modify your GUI here, but these are two things that I would add right away. So we, as a new person to Wireshark, we're preparing our environment. This is one way that I highly recommend that you modify your Wireshark so that you can see things right away. Okay. All right. We are ready for the next part of preparing your environment. So just previously, we learned about how to create profiles, adding different columns, so that when we are capturing packets, we can see visually, very quickly, specific data that we want to have shown. Okay, that would be something that we can move forward and continue on with finding malicious traffic. Great. There's other aspects of preparing our environment that are also very important. So, for example, I've got a video queued up here, and I'm actually going to be doing a voiceover of a previous video that I made. And I'm going to be demonstrating that we can actually use Wireshark to do packet captures on different virtual networks. So here's how this particular lab environment is set up. I've got a host machine, my laptop, and it's got Wireshark running on it. Great. I have two virtual machines. In this case, it's a Kali machine and a random Windows machine. Doesn't matter what the machines are, because what I'm doing in this virtual environment is that I'm putting both those virtual machines on their own host-only network. Okay, so now what that means is that these machines that are in this host-only can chat. They can chat with each other, but they can't get out and contact or communicate with other machines. That's fine, because that's the way we've designed that network. But what makes Wireshark really cool is that I can be running Wireshark on my host environment, and then I can listen in on a virtual network adapter. I can actually hear and capture packets that are happening on a virtual network that are happening inside my laptop. So we are going to move ahead. I'm gonna do a voiceover for what we're seeing on the screen here, and you're gonna see me. I'm gonna do some commentary on what we're looking at. Okay. So first off, we're going to be going and adding a virtual network. I look at what I've got so far, and I've got bridge, host only, and NAT. But I'd like to make a new one, and this is the network that I'm going to be attaching my two virtual machines to. We go in there, I click on it, and it's set up as host, which is fine. I'm going to go to the DHCP because I have DHCP running on this particular host network, and I'm going to give it a very small DHCP pool. That's fine. That's what I've selected for this particular network. I hit apply, and it's going to do some configuration on the system. And then once this is complete, we're going to hit OK, and it's been created, which is awesome. Let's jump over to the Kali machine, and I'm going to change the network that my Kali is attached to. So currently it's set to VMnet 0, but I just made VMnet 2. So let's go ahead. I set it to that. I check well, actually I go and I reboot the machine. Okay, so I've got a new network. I reboot the machine. We jump on over to the Windows machine. Go to the VM settings and choose the appropriate network that we just made. Awesome. Okay. And because we've changed the network adapter here, we need to reboot this machine. The Kali machine has rebooted at this point, and I'm going to log in as root. Next thing I'm going to do is check the IP address. So we can see right away that I am on the correct network, and it has been given a DHCP address appropriately. Let's go over to the Windows machine, log into that machine, and check to see what the IP address is on this machine, just to make sure that it got the right IP address. I hit CMD, click on it, ipconfig, and 245.11. Great, they are on the same network. And so now here I'm going to do a little test, and it might look like it's a fail, but it's actually good. I'm going to ping that machine, and it's not going to come back as anything, and that's actually by design, because the Windows machine on the other side has a firewall, which is set to deny. This is what should happen when you ping a firewall. I'm going to go over to the Windows machine now, and I'm going to ping the Kali machine, knowing that it's on the same network and it's got .10. And we have ICMP reply. Great. Okay, so we can communicate between these two machines. So what I'm doing now is I am opening up Wireshark, and you can see right away in Wireshark that I've got VMnet2. That's the network that I just made. So I double click on it, and I am currently capturing packets on that host-only network. You can see that I've got 245.10. It's been captured, and what I'm going to do next is that I'm actually going to flood the Windows machine from Kali. I'm going to send a very quick SYN flood here, and I want to see Wireshark actually capturing that data. A very straightforward flood. So it's going. Open up Wireshark, and bing bang boom. Here we go. We've got a flood occurring on that network. So what's really unique about this? What's unique about what we're seeing here is that my Wireshark again is on my host machine. I was able to select through Wireshark a virtual network and choose it. So I chose VMnet2. On VMnet2, I had two machines, and I had a Windows machine and I had a Kali machine. Those are the only two machines on that network that are chatting with each other. And then I did a flood from Kali over to the Windows machine. And as we can see it right here. Awesome. There you go. So that's how we would set up Wireshark to observe traffic that's happening on a particular network adapter, on a particular network that we are attached to. All right. Let's jump back to our outline here. So we've talked about these first three items here, and now I'm going to talk about some of my initial interactions. So in this scenario, I'm kind of role playing that I've been given a capture, and I've been asked to I've been given a clue that there's something has happened on this network, and it's weird, and we need to figure out what's going on. I'm going to go through my process of what I do when I'm first given a capture and I need to do some analysis on it. Okay, and so some tips that I can give you here is that don't get too granular right away. Don't be like, well, there's got to be a web attack. We need to look for the web attacks. Well, maybe there isn't a web attack, right? Maybe there's a flood. Well, maybe there isn't a flood, right? We need to step back a little bit. This is the part that's hard. Is that you step back and you just look at it and try to get just a general idea of like what is happening in this thing, right? You don't need to be so specific, but you can sort of get an idea. Okay, I'm going to show you some areas in Wireshark that I pick on first, and I say, okay, I'll use this part, and it will tell me something specific. If it's interesting, then I will dive a little bit deeper into it. So it sort of opens up the floodgates on certain things. So let's jump over to a Wireshark that I have, and something is happening in it, and I'm going to talk about a little bit of my process. All right, so now we're getting into my favorite part of Wireshark. It's where you've been given a capture and you've been asked to figure out what's going on. That's why I love Wireshark, because it tells the story of what's happening on the network. Okay, and it tells it from beginning to end. All you have to do is put the pieces together. It's like a big giant puzzle, and all these packets tell a piece of that story, and it's up to the analyst to figure out what's going on. Okay, so these are my initial interaction steps. I'm going to show you some aspects inside of Wireshark, and we're going to figure out together kind of what's going on. All right. So first things first, you have to clear out your brain. Get rid of everything that we're thinking about, and approach this Wireshark with a clear mind. That's important because if you go into this thing and you're zeroed in and you're looking, I know there's a DNS problem, I know there's a scanning problem, I know there's this, I know there's that, you may miss the mark, and you're focusing in on something that has nothing to do with it, and will lead to wasted effort. Okay, so clear out your mind, and this is what I do first, and it seems really low skill, but it's extremely useful, and I do this every single time I start a capture or I'm analyzing a capture. I take a look at the right side over here, and I don't pay attention really to what the colors are, but I do what I call is a drive-by on the entire capture. Okay, and I'll scan down, and I'll roll with my mouse, but I'm looking at big areas where there's colors happening, or I can see the noticeable change has occurred in this story. And when I'm going by, I can see that right away there's and you can visually see that there's a lot of black over here. Let's go down. Let's jump over to that area there. Black, some red, gray for a TCP is happening, and continue going down, and there's a lot of it. So there's a ton of traffic that is happening here, and this is not normal. We shouldn't be seeing this amount of traffic happening. So things you can do is you could look at like source and destination, source port, destination port. That's useful. But let's before we even open up a packet, let's use Wireshark to assist us in telling the story here. So what I'm going to do is I like to go, and kind of in this order as well, I like to go to the statistics drop down. Now this is extremely useful, and I highly recommend that you guys explore all of the different aspects features that we have in here, because they're super useful. I always go to endpoints first, every single time, because I'd like to see one thing. If I don't know what this network is, I'd like to see where are the private IP addresses. Okay, is it a class C, a B, an A, right? Where is this happening? Because we can differentiate DNS and Google servers and stuff. But what I would like to know is what's happening on the inside of this network. So I need to know the private IP addresses. So over here I've got a bunch of IP addresses happening, and they're all in this range. So 10 within this 10.197, I got a 167 there. 98 has got a 76. These are all private IP addresses. Very important. I document that so that I can understand who is the unique players in this particular capture. The next thing I do is I like to look at the number of packets that are happening on the network. But specifically, I'd like to see which machines are doing more talking than others. So like if I look at this machine, it's got 6 packets, not very many. 14 over here, 3 over here, but I'm obviously avoiding this one. But we've got a 42.7 and a 42.115 and 4,000 packets. Now compare that to this one up here, or let's go down to the 42 area, 42.253, 14. All of a sudden you've got 4,000 packets. That's a red flag for me, and I would document that and just say, all right, I'm gonna zero in, and I'm gonna literally write on a notebook for myself. 42.7 is something to think about. 42.115 something to think about. At this point, I'm not jumping to any conclusions. I'm just documenting the things that are a little weird. Okay, that many packets, that's weird. Okay. You can play around in these a little bit more if you so choose. But I've found something that's weird, and so I've documented it, and we're gonna go to something else in statistics that's extremely useful, is protocol hierarchy. So now open this up, and we are gonna look at, these are basically statistics on what is the percentage of that particular protocol occurred in this capture. Okay, so we can tell right away that we were capturing on Ethernet, because we've got, it's 100% of the packets are Ethernet. Fine, great. Let's go IPv4, 99%. Great. Let's go down some more. This one jumps out at me, is that it's a 98% of the packets that are in this capture are TCP. Now, that might not seem like anything bad right away, but what it is telling me is that there is a ton of traffic that is a connection-based communication. Okay, we're not seeing a blast of UDP. We are seeing a lot of connection attempts potentially. Okay, so that's something that would be a red flag for me. I'm not able to zero in and say there is a scan or a flood or a excessive amount of sins being sent out. I don't know that just yet, but I do know that a whole lot of traffic is TCP based. Okay, I make note of that. I exit out of this, and I go to another very useful part of Wireshark. I'm going to go down to, and it's called conversations. And it's a cute way to say that they're telling us, Wireshark's telling us that there are machines that are like chatting with each other. Of the packets that are occurring in this capture, which machines are sending packets between each other? Very helpful. Okay, remember we documented that it was 42.7 and 42.115. So let's go over and look at our on the address side A here, and we go down to 40. We see 42.7 over here, and I look over here, and 4,000 packets are coming from 42.7 to 115. That's a lot of packets. And in this capture, we have 4,373. Of that number, 4,000 of them are coming from 42.7 to as the destination of 42.115. Very important. Okay, I document this because now I'm getting more of a clue that something weird is happening with, and specifically 42.7. Now that particular private IP address is doing something weird. Why are they sending so many packets to this machine? I don't know. Not yet. Okay, that's another clue, and you can look in more the relationship that's happening between these things, but a lot of these are just normal things. This one here with 4,000, that stands out. We're not done yet. There's another area of statistics that's extremely helpful, and as a visual learner myself, I quite like this aspect of Wireshark. It's input-output graphs. Okay, let's go and look, and we can see we've got a we got a very basic graph here, and it's showing from the beginning of the capture to the end of the capture. And at this point in time, and I'll show you a really cool thing, we can actually select different areas, points in time in the capture. So obviously something happened here. Let's jump over to the beginning of that, get in there a little deeper, further along. So think back, remember back when I described that I did a drive-by, and we were able to see that something weird is happening over here. Yeah, something weird was happening there, and it was a tremendous amount of traffic for this in this particular capture, and it jumped all the way up to here. Okay, and then it dropped off right away. Okay, we can do display filters in this, in the input-output graph. So like at this point, you have some exposure probably to doing display filters, like filtering on TCP, filtering on HTTP. We can do that exact same thing, but do it in a graph. So let's go in and add a filter. Now I'll show you one that I like to do quite often. And typically when I go into input-output graphs, I'll actually add this filter so that I can see how this particular filter corresponds with the all packets. I always leave all packets on because it's very useful. So let's go in and add a filter. Okay, I'm going to add a filter. I'm going to double click on it, and now I've got the ability to type in here. And I like to look for this one first. TCP flags equals, and I do it by a hex, 0x02. Okay, let's give it a really ugly color so that it stands out. How about gold? Okay, so now I'm gonna when I turn this on, it's gonna tell me where do we see all of the SYN flags. This is how I filter on packets that have the SYN flag set. Okay, so we got all turned on, and we're gonna filter on TCP flags. And I don't know if you can see that very well. Maybe I'll change the color here to bright green. There you go. That's a little easier to see. It's green. Notice something very important here. We can see that the green, in comparison to the gray of the all packets, they follow along pretty closely. When all packets jumps to the top, look at what also follows along. The SYN packet jumps straight up at the same time as the all packets. When the all packets drops back down, we're seeing that the SYN packets are also dropping back down. So that's telling me right away that the traffic that's being created, and we can also see it right here on the screen, but input-output graphs verifies that very, very nicely in a GUI, that this spike in traffic is in fact SYN traffic. It's the SYN flag is set on these packets. Very useful. Now let's go and take a look again at these packets, and I'm going to try to filter out using the display filter up here. I want to zero in on 42.7 and 115, and I want to see this. Okay, and we're going to visually see it over here. So at this point, we've used a variety of things in statistics, and I kind of have an idea that's what's going on, and it's starting to look like a scan. If it was a flood, we would see this going probably a lot longer, right? But because we have a spike and then a drop right away, it's showing that the scan blasted the network and then dropped off right away because the scan was done. Okay, let's close this window, and we're going to do some display filter modification and verify that we saw a scan happening. All right, so now that we've learned a few things, we know that there's a lot of SYN packets that are being sent across this network. We also know that we've got two machines that are sending an abnormal amount of packets, 42.7 and 42.115. So now we're going to use some display filters, and we're actually going to poke around in and dig a little bit deeper to take a look at what's going on. I'm going to start with the IP that I believe is generating a lot of traffic, and I think it's 42.7. So first thing I do is, when I suspect a particular machine, I want to see everything that's coming from that machine and going to that machine. So let's go ahead and do that. So we do IP ADDR equals 10.167.42.7. It goes green, means it was a good filter. So I hit enter, and we're going to see all the traffic coming to and from this. and then I kind of start the process over a little bit. So I'm going to do a drive-by and see what's happening with this machine. And I scroll down, going through it, and we're seeing a lot of that SYN traffic. A lot of that SYN traffic. Going down, see if anything stands out, and we're kind of at this case we're verifying that I think we found the culprit here on this network. If I look at the source here and I look at the source port, we take a look and we see that 54830, and it doesn't change going up, but something does change in each of these packets, and it's actually the destination port. And you can see that we're sending a SYN packet to the destination port, which is on this particular asset. We keep going down, and these are all the interactions that were sent from 42.7. Let's go to the top, and I'd like to show you something that's important to take note of. When I'm doing filtering, I actually filter on hex quite a bit, and it actually makes my job a lot faster. And I'm gonna quickly demonstrate how that makes things faster. So let's take a look at this packet here first. So packet 254, and I'm gonna click on that packet, and we're gonna open up our panes here, and we're gonna take a look, and this is the particular packet, and this is the raw information here, and it's a SYN packet. Now, what's interesting about sort of the hex that we can see here is that when I change to a packet that has a different flag, so in this case, or flags, plural, SYN-ACK, it changes. If we go back to SYN, it changes again because the packet's a little different, but there's a part of the hex here that stays the same. And I'm not going to get you to point out, I'm going to tell you where it's the same. But if I go back up to SYN and I look over here at this hex right here, it's a 02. Let's jump over to this packet. It's a 02. Let's go over to this packet. It's a 02. Okay, and so hex 02 is the hex for a SYN packet, and this is where it lives over here. Let's go take a look at a SYN-ACK. I'll click on it and jump over here, and it's no longer a 02, it's a 12. Okay, and it might not seem like much, but man, when you use hex to filter, it's incredibly efficient. Let's go ahead and do that. So I'm gonna filter using the hex 12, and I'm gonna filter with the hex 02. So I'm going to use an operator, and I'm going to do TCP flags equals 0x12. Okay, and we're going to filter on SYN-ACKs. Okay, so we're discovering something very important, and let's take a look at the source. We have 42115. Remember, that was the other machine, and 42.7. So this is a packet coming from this machine 115 to 42.7, and look, the source port is 443, and we're getting a SYN-ACK. Very important, because what that tells us is that this machine responded to a SYN packet that was sent to this port from this machine. Okay, and if we look at what responded, so if we go down, we're seeing a lot of 115, and there's only this many here actually. I'm displaying 32 packets right now. And let's look at the particular ports that responded. Okay, 3389 RDP, 135 we got Samba, 22 SSH. Going down, we have some other unique ones, but other ones that stand out would be there was one here, 5900 VNC. Okay, so we can confirm using our filtering here that the machine 42.7 conducted a scan on the target machine of 42.115. And if we back out here, and when we scroll down, and you can see how the traffic changes quite a bit, and we're getting a ton of traffic just blasting out there. We can take a pretty healthy stab that a port scan with a high time interval was actually used, maybe T4 or T5, using an Nmap terminology. So there you go. If you're curious, we can do a little bit more on taking a look at the hex values and how fast they are. We could even do things like a null. What does a null look like in hex? What does a Christmas packet look like, right? Remember, that's a fin, push, and urge. So let's go ahead, and I'm going to demonstrate what a fin, push, and urge would look like inside of Wireshark. Awesome. What I'm going to do now is I'm going to send from my Kali machine to my a different virtual machine a variety of packets, but I'm going to focus on a Christmas packet, so which, as we remember, is a packet that has the fin, push, and urge packets flag set. So let's go ahead. I'm going to start a new capture on the virtual network, and we're going to zoom on over here and take a look at the command that I have here. I've got hping3, fin, push, and urge flag is set, and I'm going to do a count of 50, and I'm going to go towards this machine here, 245.11. Okay, so I'm going to hit send on that, and we'll go over to the other side, and if we look, we can see some fin, push, and urge packets set. I'm going to cancel this. We've stopped it, and now I want to take a look and see what the hex looks like for this fin, push, and urge. I'm going to select that packet, and we're going to zoom on down here, and let's take a look. Remembering back that when I pointed at this spot in our hex, it is the hex value for the flags that are set. So we have a 29. Okay, hex 29. Let's go and actually filter out all of the traffic. So right now I have about 95 packets. Now what I want to do is I want to filter and get only the packets that have fin, push, and urge set. So let's go ahead and do that. And TCP flags equals 0x29. And there you have it. We have all the packets that were sent from my Kali machine towards my other virtual machine, which is the 11 address. And we can see that we've got all the packets that have fin, push, and urge set. Awesome. We can do this for all of the packets. So if there was a SYN, it would be 02. If there was a SYN ACK, it would be a 12. And in this particular case, we've got a 29 that's represented. Now, every single combination of flags has its own hex value, and that's what makes filtering on hex values so efficient, because I don't have to do multiple statements in my display filter to grab the data that I want. Awesome. I do have a video, and I'll add it to the description, that explains how to convert binary to hex and hex to binary, and it's very useful when we want to think about how can I manually do this without sending fin, push, and urge packet. How would I do that? There's a link in the description. So before we get to talking about scans and floods, it is important to actually talk about what is malicious, right? And when you talk to different people, and this is my conversation I've had with security analysts and other security professionals, is that like what would you define as malicious? And I think there's a key word that kind of needs to be tacked onto that, and the word would be intent, malicious intent. So if you think about the concept of a scan, right? I could scan my network to discover hosts on the network, and that's not malicious, right? Because this is my network and I want to understand what's on the network. I could be hired as an admin for a client, and I could do a scan on the network to understand what are all the assets that live in this network. That's not malicious. That's part of my job. However, if we put the word intent on there, if I was a person who has ill intent, how would I figure out what's on this network without doing a scan, right? I would like to do a network scan to discover potentially vulnerable targets to hack and exploit further, right? So we have to think about what is the intent of that. Obviously, there's things that happen that are malicious, like ransomware is malicious. Various worms, when we travel in the internet and we download, we're on phishing sites or we're in drive-by downloads. Those things are malicious by nature. But you do have to consider that sometimes a scan can be malicious because it can have malicious intent. You know, there's also a scenario where we could use a flood as a malicious tool, but we can also use floods without malicious intent. Right? I'll pause there while people go, what? Denial of service? Those are always malicious. Well, not necessarily, right? What if I'm an admin and I want to test a firewall, right? I want to see if that firewall can handle a pummeling. How do I know if it can handle it? I'll launch something at it, and if it can take it, then I know that it's in a good place. So we got to think about what is malicious intent. Okay, we can for the most part clearly understand what is bad by default. You know, ransomware, etc. I've talked about that now. But think about what the intent is. If on your network you find out that there's a scan happening, but you did not know about it, and you did not sanction it, and you did not say this is okay to be doing a scan right now, maybe there's something bad happening. Maybe somebody has malicious intent, right? You should go to that machine and you'll be able to know it because you can see the packets flying out of that machine. Go and figure out and say, hey, are you doing a scan? And if they tell you, no, I'm not doing a scan, you got a problem happening on that machine. You isolate it and figure out what's going on. But we'll be able to determine that through a lot of tools, but like Wireshark is what the nature of this video is, explaining that, and we can see scans happening. So let's go ahead and take a look at scans and floods and learn what they look like in Wireshark. Okay, so we've learned a bit about hex, some filtering. Filtering can get quite deep, but what I'm going to show you now is when a scan is conducted, what does that look like when it's running in Wireshark, and when I do a flood, what does that look like in Wireshark? So what I'm going to do here is I've got two machines that are on the same host only network, and I'm going to queue up a scan here. First off, I'm going to get Wireshark running on the appropriate interface. So it's capturing stuff, and now I'm going to send out a scan, and we're going to zoom over there and see what looks different. Stop the scan. This is on a very quiet network, so that's why I put it in this host-only environment. We can see very quickly that a scan has happened. If I go over to Kali, we can see that there are a variety of ports that are open. So ones that let's pick on 135. Okay, let's go back over to Wireshark, and we can see that these are all the interactions between this environment here. Let's go and take a look at reset ACK, and if we look at this, I clicked on the reset ACK, and its TCP flags, the hex value is 14. Okay, now that's useful because I'm going to do something right away here, and I'm going to filter out these resets. Okay, I want to get the TCP flags of SYN, so I want to get SYN flags. I'm going to use an operator of and I'm going to filter out TCP flags 0x14, and I should only get SYNs here. Beautiful. So I got rid of all of the reset flags. Now, when these are just SYNs. Let's scroll down, and these are all of the SYNs that came from 10 over to 13. And now we don't see any of the responses, but we do know that we did get some responses. Okay, but before we do that, I want to take a look and explain a little bit of what's going on here. So we know that we're dealing with a scan when we see a ton of SYN packets. Now, there's a variety of SYN packets that can be sent out, and the nature of a scan is that it will evoke a different response from a target machine. And so that's our job as a security analyst, is to understand what are those responses. Like when I send out a SYN, what am I expecting back from an open port, from a closed port, from a filtered port? When I send out a SYN packet, what's the anticipated response? Okay, knowing these things and the way that the natural communication happens really enables us to use Wireshark effectively. But right away, we know that we worked with a scan because if we look at the source IP, it didn't change. So we know that this machine is actually doing something repetitively. Tick, 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 tick. Additionally, we have a source port, and it does not change. Okay, so that's important. However, the destination IP doesn't change, which shows us that it's one particular machine that's being engaged. But the destination port does change. So it's a new connection attempt to a different port on the same machine. Poke, 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 and these are all different IP addresses as a destination. We are sending all of these packets out, hoping that we're going to get a response of SYN ACK back to the sending machine, which in this case was Kali. And we would get a response we got a SYN ACK on these. So let's go ahead and look at that response to, let's do 135 like I said before. I'm going to put in a filter here, and I'm just going to be TCP flags equals 0x12, which is SYN ACK, and TCP port 135. Okay, I get a single packet back, which is great. And we know that we got a SYN ACK back, but we're using Wireshark. We can see this packet, the successful communication. The source was our target machine. The responding port was 135, and it's coming back to my attacker, which is Kali. In this case, is number 10, and we get a SYN ACK TCP. Okay, awesome. How about this? Let's modify our filter again, and I only want to see the SYN ACKs. Awesome. We can see that these are all of the SYN ACKs that came from 13 over to 10. And if we compare this as a side-by-side to the ports that we got from our scan, we can see that, yes, in fact, 80 was responded. 21 responded. 135 responded. 445, etc., 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 etc. These are all the ports that respond with the SYN ACK. So we know that a SYN scan happened on this network. Awesome. We figured out what happened. Let's go and do a flood now and see what that looks like. All right, let's go ahead and flood this machine. I'm going to send a very simple hping3 command over at our target here, and on the other side I've got Wireshark capturing, and it's just all the stuff that we can see over there is just normal traffic. But let's go ahead and flood it and see what changes, what happens. Right away we can see a ton of SYN packets happening, and the machine is attempting to respond to it, but failing because it's just getting a lot of garbage. I'm going to kill the flood and stop the capture, and then let's go ahead and take a look and do an analysis on this machine here. So right around here we can see that the flood started. So you can also see that there's this gray over here, right? A tremendous amount of packets are matching whatever gray is, and in this case it's a SYN. But let's look at the difference here. So I want to get the IP of this guy. Kali is 245.10. So this is my source IP here is my Kali machine, and my destination is number 13. And the packets are same source, same destination, and we are doing a denial of service right now. But what's really unique about this is that if we look at the source port, it's going up sequentially, tick, 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 going up and up and up and up and up and up and up. But the destination port is not changing. It's staying the same port. We're trying to connect to, and in this case it's port 0, which is nothing. But we could have changed our flood to be port 80 or port 21 or any of the other ports that we know are open and would respond to this flood. If we were to change it to port 21, what would happen is that this destination port would look like 21, and it would be the exact same all the way down. So what differentiates a scan and a flood has the source port changes, and the destination port is staying the same. And in a scan, the source port is staying the same, and the destination port is changing. All right. Hey, if you're enjoying these videos, please go ahead and like and subscribe. It would be great, and I look forward to talking to you soon. See ya.